Hi, and welcome to the first Meet the Masters session with Rob Suryan and Leigh Torres. My name is Amanda Gladix, and I'm a faculty research assistant at Oregon State University. And I finished my master's degree in 2012 and have been working in seabird research since then. And we've got a great group of early career scientists with us today, and we're going to go around and do some introductions to get started. Let's start off with introducing our masters. You guys want to introduce yourselves?
Hi, my name is Rob Suryan, and I'm an associate professor of senior research at Oregon State University, based out of the Hatfield Marine Science Center. And I've been studying seabirds for about 20 years now. Was when I first got my first job, field work studying marine birds. Before that, I was studying marine mammals and terrestrial animals. And I do a wide variety of studies ranging from spatial ecology, but also population dynamics and foraging ecology.
I'm Leigh Torres. I'm an assistant professor at Oregon State University, based also here at Hatfield Marine Science Center. I'm a spatial and behavioral ecologist. I study mainly seabirds and marine mammals. As you can tell, my voice is a bit scruffy. I'm just getting over a cold where I lost my voice completely. So my answers might be a bit short today, but hopefully I make it through the full hour. I'm really excited to be here, so thanks.
And I'm Emma Kelsey. I'm an early career scientist. I finished my master's in the summer of 2014 and am currently working for the USGS.
Hi, I'm Dilek Şahin from Turkey. I'm a PhD student in Boğaziçi University, and I've been counting especially Yelkovan shearwaters in the Bosphorus. It's a narrow strait in Turkey for 5 years now. And my focus is, of course, seabird ecology, and I will try to discover all the facts about Yelkovan shearwaters in Turkey.
Hi, my name is Nicholas Pershufeld, and I have a master's degree from the University of Copenhagen, and I'm currently doing a PhD at Wake Forest University in the US.
Hi, I'm Licia Calabrese. I'm a PhD student at Paris University, and I work for Islands Conservation Society in Seychelles. My PhD is on 2 species of shearwaters breeding in Seychelles, and I'm at the 3rd year.
Hi, I'm Corey Clatterbuck. I also got my master's last summer, and I'm currently a first-year PhD student in the joint program in ecology at San Diego State University and University of California, Davis. I'm mainly interested in emerging contaminants and spatial and temporal trends in those emerging contaminants.
And I'm Schurer from the University of Glasgow, and I'm supposed your co-host. My research interest is in great skuas, the egg production and ecotoxicology of great skuas. And of the things that I should mention before we get cracking on with the questions is that we invite everyone, also viewers, to ask questions live. We have our panel with early career scientists here, and their questions will get priority. But still, we hope that listeners and viewers will be able to send us some questions, and they could do that in 1 or 2 ways, using the hashtag MTMSC on Twitter. Or they can comment on the YouTube or Google Plus broadcasts, which we are doing right now. So Amanda, what?
Thanks for all of those great introductions. I think we'll just go ahead and dive into questions, because I know we have a lot of questions lined up, and I thought we'd get started with a question from Emma Kelsey. You had a question about alternative career paths.
Yeah, so Rob and Leigh, my question was, did you ever consider a career outside of academia? And in your opinion, what are the pros and cons of working in academia as opposed to other types of positions, the government or NGOs or something like that?
Well, I guess I'll start off, and the answer is yes. And I think early on in my career, having considered all those options, from government agencies to NGOs and also academics, and I guess I really never settled on having an academic position until after finishing my PhD, and even a couple of years after that. So my route was a bit circuitous, but I think was beneficial in the long run. I actually have worked for agencies quite a bit, not only just during seasonal field jobs, which I'm sure many of you have too, but also between my master's and my PhD, I worked for the U.S. Fish and Wildlife Service up out of Anchorage, Alaska for 6 years. And I was working on a seabird and forage fish study. So it was a research project funded by external sources. So it was more of a research position, but it was within an agency. So, and I really enjoyed that experience. It gave me a good perspective on the two different aspects of work in the different within different organizations. Boy, I guess there's certainly a lot of benefits to both of them, and I work with a lot of agency scientists too. And I think in terms of from an academic perspective and working at a university, there's an enormous amount of freedom in what you're able to do, and who you're able to work with, and where you're able to work. Really, it's a matter of your imagination drives whatever you want to do, and as long as you can fund that work and get enough people interested in either supporting your work financially or students working with you, then you can be as creative as you want and follow different directions. So I really like that a lot. It's also very challenging because I think you're really pushed to excel in every aspect of your work, and I think in many respects that's a benefit, but also it can consume a large portion of your life too, and you have to be careful to maintain good life balance. And then also, working with agency scientists, like I said, being one for a little while, but also working with them. One thing I've really enjoyed about that that environment is that you have quite the infrastructure to support lots of different aspects of your work. Not only in that you have your, the office and colleagues that you're working with, but they often have a lot of equipment and field stations and just a lot of field research and then also applied research applications and opportunities that you don't get as an academic scientist. And you build your collaborations as academic scientists, but sometimes you almost feel like you're alone at times trying to reach out to collaborators to bring in, whereas within an agency you're instantly, when you get that job, you have an instant pool of collaborators within your office. Yeah, lots of other things I can say, but I'll pass it off to Leigh too.
Well, you pretty much covered it.
Okay.
So I don't have that much to add. Just to reiterate that, yeah, I mean, I've dabbled in a few different agencies and groups getting to this point in my career, and yeah, certainly here it's all about freedom, and that's great. It's liberating, but it can also be overwhelming. So there's a balance there. So yeah, academia is great for that perspective, and if you want to work directly with students, which is quite rewarding in that aspect. But yeah, all the caveats that Rob brought up are certainly true about the competitive nature of academia and really the responsibility that falls on your shoulders to get things going, as opposed to at other agencies and groups where maybe you're more directed in what you should be doing with your time.
Yeah, and from the teaching side, it's actually really fun to be able to take what you're doing from the research side and integrate that directly into your teaching too. So it keeps you very well rounded, because you have to know or relearn all the basics to teach, while incorporating also, I think, the latest and the greatest with the research that you're involved in too.
Great. Does anyone have any?
Thank you. That was very helpful.
Does anyone have any follow-up questions to that? Okay, well, I think Corey actually had a question that's somewhat related about graduate school and knowing what you know now. Would you have done anything differently? Is that? I'll pass it over to you, Corey.
Yeah, I mean, it's a bit more of a general question, but you know, I'm kind of in this place where I'm trying to figure out what topic should be on my orals. You know, what can I do right now that will drive the research that I need to publish, you know, in 3 years? And so I'm kind of wondering if you all could do anything differently in grad school, what would it be? And kind of as a part of that question, what kind of spatial techniques or prep would you recommend for that goal?
Should I start off?
Yeah.
Okay. Yeah, that's a deep question. Let's see. I think as far as my, I guess the way I approached graduate school was actually very different between my master's and my PhD. So during my master's degree, I had only been out of school from completing my undergraduate for about 1.5 years, working field jobs. And then when I went back to graduate school for my master's degree, I had the opportunity to really participate in lots of different student projects and faculty associated projects that I think gave me a really good perspective on, in terms of marine science and all the different aspects of potential directions to go. I was at a marine lab. I was at Moss Landing Marine Labs, and it was just a fantastic opportunity to gain all kinds of experience. And that really helped shape the direction that I wanted to go. I still, after finishing my master's, I didn't know specifically what I wanted to do, other than I wanted to remain focused on studying the marine environment. But also, at that point, I decided that I wanted to focus on marine birds. And so that set me on the path of excuse me, studying marine birds, but very general from an ecological perspective. And then my PhD project was very different in that, or my experience was very different, because I had been out in the job force for 6 years before going back to my PhD studies. And I had been already conducting research, publishing papers, working with my supervisor at the time and others. And so I had funded my PhD work through bringing grants in during that time, and actually had brought in more money to have students. So when I was working on my PhD, I was acting in some respects more like a PI than a student, even though I was taking classes, but I had all these other responsibilities too. And in some ways that was good to launch me into my career after my PhD, but also I felt like it was a bit restricting in that I didn't get to experience graduate school at the PhD level like I did at the master's level, where I had a much more freedom to really gain lots of different experience from working with other people, because I was pretty much tied to my own program at the time. But I think what's a couple things to keep in mind during your any graduate program is to develop. That's really the time you have to develop the skills that you can apply for studies beyond that degree. And whether you're studying marine birds, marine mammals, insects, forest animals, or even humans, that to take along a very strong skill set of either quantitative analyses or spatial ecology, like we're talking about, whether it be GIS or some type of computer programming like in R and MATLAB, and or I guess genetics or food web studies. I mean, take along those skills that you can move in any direction. And actually, when I was working on my PhD, that's when I really started programming a lot in MATLAB. And I know a lot of you students do already, and you also use R. And I think those are incredibly important skills, because as ecologists, the data sets that we're using are just getting larger and larger, and we're deploying instruments that we're collecting massive amounts of data. So we're, in many respects, us biologists are acting like engineers now with these technology deployment and massive data sets that we're working with.
Cool, thank you.
Leigh, do you have anything to add on to that in response to that question?
Well, Rob hit it on the head with his last point there about trying to develop your skills that you can apply to a broad range of things. I would recommend that you don't pigeonhole yourself in like one species or taxa or something, and think about the skills you're developing as well as the knowledge, the ecological knowledge about your system or your species, because then you'll be much more employable. And then in terms of what I do differently, I thought about this question a lot because, I don't know, I went back and forth. When I did my PhD, I sort of had my own I had a project I wanted to do, and I went out and I got funding for it, and I did it, and I worked closely with my advisor, but my colleagues around me were actually working on projects that my faculty advisor had gotten funding for, so they were more sort of involved in day-to-day operations with him and other faculty at the lab, and sometimes I think that would have been better, that approach. I would have formed more links with faculty members and things like that. But on the flip side of that, what I did also gave me a lot of skills, because I wrote a lot of my own funding grants. I learned how to do that, which was a big thing. That proposal writing is a constant throughout your career. So learning those skills, and when I finally got funded, it was like a huge moment. And then I developed my whole field project and all of that, and that again was great skills for me, as opposed to somebody telling me, well, this is what we're going to do, or having it more laid out. So there's flip sides to it, and I don't know which is better. I mean, I landed on my feet here, which is good. So, but sometimes I think that having some sort of broader connections would have been great too. I don't know. It's hard to know which is better.
Yeah, totally. And yeah, being able to link with different people and in different labs, I think that's one of the huge pros of my program right now. So I'm happy to hear that you think that that's a good idea.
Yeah, for sure. I mean, outside of my project, my PhD project, I collaborated on 3 or 4 other projects, where I got publications out there, sort of totally ancillary to my project. I think totally recommend doing that as much as you can. Collaborate and work on as many projects as you can manage time-wise. Yeah.
Yeah, that's a good point. Those network connections are really key throughout the rest of your career too, and your web starts just becoming larger and larger, and it's really exciting in that respect too.
Thank you, guys.
Great. So we have a lot of questions about sort of spatial ecology principles and sort of conservation implications and trade-offs. And I'm thinking maybe I'll hand it over to Leigh. You had a couple really good sort of conservation trade-off questions.
Yes. In fact, I did work for ICS, so Island Conservation Society, for Seychelles for 4 years, and before starting my PhD actually, and being on the field, I realized how difficult it is to have funds for conservation, and but it's very important to develop the science behind the conservation as well. So if you had a certain amount of money, whether you choose to invest it in developing more science to go a bit deeper in certain species or certain ecosystem knowledge, or to be a bit more specific on stakeholders and on education at school for the new generation, or convince politicians that actually conservation is important.
Wow.
That's a very good question. It's a constant balance and struggle. I mean, I just off the top, I would say that it's probably case by case.
Yeah.
But I don't know. What do you think?
Yeah, I would agree. It's definitely a case by case, and I think some of the decision points, I guess, that I tend to walk through are, first of all, what is it that the resource needs? What would most benefit the resource first? And is that obtaining some basic information about its ecology, what's limiting its reproductive output, or what's limiting the population in general, and then make that decision. Because oftentimes, at least I found that I mean, I really love doing basic science, but in terms of getting projects funded, really that's the question. The money, I think, follows that question. Is that what if it's a conservation concern and you're doing conservation science, the money is going to follow whatever factor is limiting that population. So if it's unknown what's limiting the population, then you dive right into research to find out what it is. If it's known, but you know, to some extent, but you need more information, that again requires research. If there's a known human impact that can be solved through lobbying or through the political system, then that's where you go first. But I guess as a scientist, I tend to want to collect all the information that's possible to make the best decision. And my focus is more of collecting information and providing that information to help the resource to as many people need it as possible, whether it's conservation organizations, NGOs, or also politicians too. So I just want to inform the processes. And I generally don't do, I know there's a lot of, I'm sure you've heard a lot about this discussions, whether scientists should be lobbyists, things like that. I want to work with all groups, and I want to provide them with information so that we can all make the best decision possible.
Yeah, and also I believe more information you have, and then stronger is your like you can defend your idea or your goal, but also at the other side maybe you have some urgent things to address, like poaching, something that is very urgent and cannot really maybe wait for a publication to come out, or so yeah, you're right. I mean, it's a very continuous trade-off based on case by case situation, and it's not really easy to to find the right solution, because then it's complicated.
Yeah, I think Rob, I mean, his answer's great, but I think it's a very scientist answer.
Yeah, sorry.
It's very much, trying to get more data and providing it. But, on the flip side of that is sometimes, like what you said, where the issue is, and if you're not just wearing your scientist cap, you want to be more of an advocate or an educator or a conservationist. And some people, we all fall along different parts of that spectrum, from scientist to, I don't know, pure advocate or lobbyist. Mm-hmm. And you can wear different hats at different times, and you have to be careful how you communicate and disseminate the information that you know. But sometimes your funding can go, if you really are interested in conservation and making a change, sometimes the bits of money could be more directed at education, or at a media campaign or something. If you really have a targeted problem that you want to get at, and you have the data already in hand that that's the problem, then you can make choices, I think, about where you want to spend your money when it's limited.
Yeah, I think your point is important about along those lines too. I mean, knowledge is really power in science and conservation, right? So you have to have that information to know which direction to go to serve conservation. But also your point about whether if you have information that's valuable before being published and not waiting for it to be published. I think that's critically important for scientists to provide their information, even if it's pre-publication, to meet these conservation goals and to benefit conservation.
Okay. Thank you very much.
So I think Nicholas had a follow-up question to ask. Is that right?
Yeah, so kind of along those lines, now that we're kind of brought up outreach, scientific outreach and advocacy, and I mean, there's been some discussion as scientists, we have a duty to disseminate our research to the general public so they can at least be informed of or have educated information so they can make educated decisions. But as established PIs, how or what is your opinion on how much an early career scientist or a graduate student should participate in this, well, within disseminating information, and at what scale is appropriate, and what kind of risks are involved with participating in this sort of activity?
Do you want to take the lead on that one?
How's
your voice holding up?
Yeah. I don't know. I mean, it's a constant challenge, I find. I can tell you that I've found myself being more outspoken about the information I'm finding throughout my research in a conservation setting. I'm being more outspoken about what I'm finding and what I think should be done than I used to be. And I think that's probably a few things, you know, just being more established in my career, having more confidence, getting more frustrated with the status quo and being willing to stick my neck out a bit further here and there.
Yeah, I think that is a good perspective, and also I think it is important to consider where you are in your career. And I think earlier in your career you have to be more cautious, not only because you don't want to influence others' perspectives of potential biases that you might have, or whatever it is, some future employer that might not be too happy with what you said in the past, but also because when I think back on earlier in my career, there are things I felt like saying back then that I'm really glad I didn't say now that I look back at it. And so I think it's important to, especially as young scientists, you have all these opportunities to publicize what you're doing with social media. And I think it's fantastic, to be honest. I think it's really good. But it's also, as you have all heard, it's something you have to be really careful with. But as your career develops, I think then, as Leigh is saying, you become more comfortable, more established, and you can, of course, get away with more too, in case if you do make mistakes, because there's a long history of you not making mistakes before that.
I would just say, and I guess this is obvious, but you know, when you do want to, you know, stick your neck out and be a bit more of an advocate, just make sure that your data is robust and that you got it all straight before you go, you know, that extra step. But yeah, it's really important these days. Very, very little of the work that we do is not applied, doesn't have some management implications. So yeah, so sometimes linking in with other advocacy groups is important. You do your work and then you sort of hand off your results to some other group to actually go out there and lobby for you and take it that extra mile.
Yeah, that's a great point. You can leverage the efforts of other people.
Yeah.
They're all part of your partners, right? Your collaborators.
Right. Exactly.
Yeah.
Great. So I want to pass it over to Dilek. Let's see if your sound is working for us today.
Hello. Now I change the focus into seabirds, and my question is a bit a general question. My first question is, what are the most important factors affecting at sea distribution of seabirds?
Okay, the most important factors. Well, one certainly has got to be food, right? So the birds are going where the food is. And there's the other aspects of that include, you know, I guess what's driving where the food is, but then also what's within their limitation to access to, whether they be, of course, central place foragers during the breeding season having to return back to the breeding colony, or if they're during the non-breeding season and free to roam wherever they want to go. So I think, and this is one of my first studies involving seabirds was a seabird forage fish study, and that really, I think, gave me a great perspective working with those scientists and collaborators who are studying prey and birds to really link together those more detailed aspects of what drives bird reproductive success, populations, and distribution. And so I think that's always top on my list for where they're going. And to some extent, you know, what we've expanded into with a lot of this remote technology and spatial ecology is a lot of remote sensing of the habitat, remote sensing of the birds. And I think there's a lot that we, of course, have learned on the global scale, on the large, you know, macro scale, but unfortunately, I think to some extent we're a bit removed from what's actually happening out in the environment when we're conducting those studies. So I think it's really important to get both perspectives. Like if you're doing broad scale, you know, satellite tracking and of animals and satellite remote sensing, that you actually get out on a research vessel to see where those birds are going and see where the prey is, and work with physical and fisheries oceanographers to see what's driving prey distribution and habitats for the animals. So I think from a bottom-up perspective, that's an important perspective to have. And then other things that are driving their distribution, I mean, of course, there's a lot of discussion with climate too, right, in affecting their at-sea distribution. And fields of study that I'm really not that involved in include contaminants, which I know some of you are, and that's certainly, you know, I think a really strong emerging field with spatial ecology and with the plastics and contaminants, to be able to start looking at some of our distribution data and also trying to map out hotspots of where they might be obtaining these, you know, either contaminants or obtaining plastics, and in some respects that could be affecting their distribution too. And then I think we're in a novel situation here too with the recovery of many large predators, consumers in the ocean. You know, return of whale populations, and some of our work at Seabird colonies, return of the native predators like eagles and things like that. So there's no doubt that I think some of our distribution, I guess, topics have been very much bottom-up focused, which is what I initially described, but there's also some top-down influences too, or competitive, you know, competitive exclusion or just competition that's driving some of these distributions too. And I think that's an important perspective for us to really move forward in the you know, in the coming years.
Great, thank you.
Leigh, you seem like you might need a few more minutes to.
Yeah, no, I'm okay. He covered it. That was good.
Okay. Let's see, Litia, you had a follow-up question to that?
Yes, yes. In fact, in the latest years, the distribution of seabirds at sea are also important to eventually identify marine important bird areas. And but so also BirdLife have been using this technique, but like my doubt was because the resources are moving, like we cannot really identify marine important bird areas like we do for the terrestrial ones. What do you think is the limit of this technique, or the advantages, disadvantages? Can we really set up offshore network for marine important bird areas, or there might be problematics related to stocks of fish movings or or this kind of things?
Yeah, I think that's a really good question. I think you're exactly right, because we have to incorporate not just the spatial dynamics of a system, but the temporal dynamics. And so there's obviously annual variation as well as just natural variation. And then with climate change, habitats are going to shift and move and change. And I think that's the strength of habitat modeling, is because if you can account for what the environmental variability is that's driving a species distribution, then you can apply that to different temporal periods, and the habitat should theoretically shift. The predictability of any particular habitat should change as the environment changes. So I think from a management perspective, they need to be able to account for temporally as well as spatially dynamic IBAs or MPAs, whatever you want to call it, because static MPAs don't work, well, I shouldn't say don't, but frequently don't work in marine settings for the reasons we just talked about, and especially for these, really mobile megafauna like seabirds that, can shift their distributions quite readily to account for the distribution in their resources. So I think, MPAs are great, or IBAs, but we have to be willing to reevaluate them every, let's say 5 years, to account for just changes in habitat, changes in, the ecology or their social behavior or whatever it is that's driving that population. I think it's really naive to just put in place static MPAs and expect that they'll work forever.
Yeah.
Yeah, I think the only addition I would have is that I think they're thinking along the physics, the mechanisms that are promoting those hotspots, those high-use areas, is that in some situations the static ones a static either hotspot or important marine bird area or marine reserve can be effective if it's generated, for example, if it's a topographic or hydrographic feature that is persistent in time and space. So, for example, tidally driven upwelling systems. I mean, a good example, an area where I work, is the Aleutian Islands. The passes between the Aleutian Islands, it's all, the movement of water current through there is in part wind driven, but also very strongly tidally driven. And we have some of those features along these upwelling coasts too, and I mean all throughout the world, where those features are persistent enough to be valuable as a static marine reserve. But I think the more dynamic ones that we were discussing, Leigh was referring to especially, that's a big challenge.
It's very hard.
And I'm not sure. I think we'll eventually get there, but I think we're a long way off from being able to establish a dynamic. Like, for example, in the North Pacific, maybe the transition zone chlorophyll front. I can't imagine having a dynamic marine reserve or MPA or IBA that is associated with that. Maybe in the future, when everything on Earth is wired and we track from our smartphones, and you can tell exactly where that feature is and move away from it, or not fish in that area.
I agree completely. I think it's just a goal we need to keep working towards. And but like for now, like I think establishing static MPAs is good, but then reevaluating them, because things change throughout time. And
that's true.
So even if they're not dynamic like daily or weekly or monthly, but that we're willing to reevaluate them periodically to see how they're working and see whether we need to change the boundaries.
Yeah, or maybe for the moment, for example, for tropical places like where I work, there's also, I think, a big problem about overfisheries, so overexploitation of resources. So maybe as a starting point, we could just say, okay, first of all, we stop overexploitation resources, and then we can see how the population respond. Because yeah, I think in the Indian Ocean in general, this is a big problem, which is not always possible to address because, of course, the economical interests are so high. And already, I think, trying to put boundaries on this in this sense could help a little bit until we maybe find a spatio-temporal answer to what we are trying to find out. Like, but yeah, it's always very difficult as well.
Yeah, we need our management structures to catch up with our knowledge, right?
Right.
Let's see. I think we had a question from our online audience. Shu, do you want to ask that one?
Yeah. We had a question from Elizabeth M. Phillips, and it's something Rob already touched on. She says, both of you use a lot of new and cool emerging technologies. This field is expanding so rapidly it can be overwhelming to me. When approaching the analysis of this type of data, where do you turn? Recent peer-reviewed papers and the model stats they use, collaborators with quantitative training outside statisticians or modelers. I'm struggling to follow. Classes, seminars, textbook, R packages, etc. Any advice of those of us facing these challenges? So, yeah.
All of it. Well, to me, it really depends on the question that you're trying to answer with your data, and let that lead you to your method. Don't let the method lead you to a question. So, yeah, I mean, it can be overwhelming. I mean, it's overwhelming for me. I'm constantly learning about new methods and techniques and trying to stay up with the literature and all that. That never ends. But yeah, really staying focused on what your data can actually answer. I mean, because there's limitations to what your data can do, can provide you, and then really what the question is that you're trying to get at. And then yes, start, I would say, delving into the literature and that narrow field. Try and keep your interest and your methods narrow, because otherwise you'll just mushroom out and go down so many rabbit holes you'll never find your way out.
Yeah, and I find at this point in my career, as much as I'd love to learn lots of new techniques and new applications, I don't have the time to do it. But I guess I play more the role of thinking about what we could possibly do, finding funding to do it, and it's all about collaborators. And I think, you know, your Elizabeth's last statement about it being overwhelming, absolutely. I mean, I don't think it's possible, as Leigh said, to know it all, and I think that's why it's so important to have collaborators. And I really enjoy, especially at this point in my career, trying to bring together the strongest possible team to address all the different components of a really exciting study that you need to do. So in many respects, like Leigh said, you know, pick which technique, and, you know, let your question drive what method you used, but also follow the path what you would like to do with your career and what you think is innovative and interesting, and become really good at that, and work with others who are good at other parts of that study or of spatial ecology, and combine your efforts. And I think that's one of the reasons why you see it's very rare to see single author papers anymore. In fact, I don't have any single author papers. I've been criticized for that, but I really like the collaborative work, you know. So
it's very hard.
Partnerships is key.
Thanks. Amanda, where
Great.
to next?
Yeah, well, I want to just acknowledge that I know Corey has to leave a few minutes early, so if you need to pop out, just go ahead. We really appreciate you coming and participating.
Thank you. Yeah, it's been wonderful. I'll probably stay on for a couple more minutes, but yeah,
Great.
I really appreciate you guys doing this.
Great, thanks. I want to make sure that Nicholas gets a chance to ask one of his the questions that he prepared. Do you have anything you're dying to ask, Nicholas?
I can ask, yeah, one of my questions. The rest of them have all been pretty much answered in one way or the other. But one thing that hasn't been touched on is I know that technology is limited, but we can kind of make some hypotheses and theories of how sociality can drive seabird aggregation, and in this thought, it could also drive any other marine top predator. So so how do you think sociality affects seabirds and their decisions during the breeding season and outside of the breeding season?
Okay, I think it's hugely important, and it's not something that I've really studied, but I've been really interested to hear about other studies that are looking at these questions. And I think what some of my early introduction to this, when we think about kind of the social networks of seabirds, right, and information transfer hypothesis with colonial nesting, etc., and the use of feeding flocks, those kind of more social questions and for marine birds. And one of the earlier studies I was involved in with marine birds, we were showing, based on my supervisor at the time, some earlier work he did, and then some subsequent work that we followed up with, where we were tracking individual birds manually, and we were watching these birds bypass feeding flocks and go forage on their own. And it made me really think about our perspective of are these kind of social aspects of, for example, foraging flocks, how important are those to marine birds in all environments? And are those just what we're drawn to because they're big and we see them from a research vessel? But there's certainly lots of good examples, like the work done in the eastern tropical Pacific and in other areas where there's associations with tuna schools, and group foraging is a must in many of those subtropical environments. And kind of where I'm going with this in terms of technology too is that I think what's really exciting are some of these tags where they're keeping track of.
That's what I was going to mention.
Yeah, which many individuals tag. Yeah. Earlier they were called business card tags, but there's other ways, other terms that have been used. But where these every animal is, or not every, a large portion of the population is tagged of your study population, and information is transferred among individuals when they encounter each other, and also with a GPS location that goes along with it. So it's there's spatially explicit social associations. Some interesting work has been done with corvids and other studies on terrestrial environment, and some with marine mammals too, right? But anyways, I think that is going to open up the field of, I think, to address a lot of really interesting questions along the lines of what you're describing.
Yeah, I was just going to mention the same sort of network analysis. I'm familiar with the crows. Right. Yeah, and so they know pretty much who they're associating with and when and where, and so this crow study was about tool use transfer between individuals and how pretty much the whole community is networked together to transfer information. And so applying things like methods like that to, seabirds would be phenomenal to look at, like, what happens at the colony when individuals come back. Do they actually transfer knowledge about where they went foraging? That's a whole field that hasn't been really dug into at all. And now with these methods, it's really exciting, and I think it's a great new field to go into.
Yeah, especially also during the non-breeding season too, right? To see what associations there were away from the colony. Also, when there's to some extent, like in some of the terns and other species where there's post-parental care too, to see how long that lasts, and some of these more semi-precocial species. Mm-hmm. Yeah, that field's wide open, and we're now developing the technologies to be able to do that.
All right, Nicholas, you got some marching orders now.
Sounds like it.
Good luck.
Yeah.
So I think we just have time for maybe one more question, and I think Emma is going to bookend us here with the first and the last questions.
All right. Well, I'll try not to make this too much of a doozy right here at the end, but it's kind of, as an aspiring conservation biologist, it's hard not to get discouraged with just, the state of our world and climate change and all these sorts of things, and can I really make a difference? So I was just wondering if you guys have any like how do you stay motivated and inspired to keep doing all the awesome work that you're doing?
You want to start off on that one?
No.
Okay, I would save your voice a little bit. Okay, so I don't have a problem staying motivated. I think it's really exciting. I guess I'm, to some extent, the glass half full or 90% full most of the time. Despite all the negativity we hear, and despite the the potential of some of these large-scale changes like climate change and ocean acidification, which a lot of these we have some indication of what the impacts might be, but we don't know exactly yet. I think there's a lot more good, a lot more impressive conservation action. I think in terms of conservation, we're way far ahead of where we were 40, certainly 20 years ago, 30 or 40, or definitely 100 years ago, or 50 years ago even. And I think we're on a good trajectory. And I think we're moving in a good direction of having science inform conservation efforts. And I think having lots of young scientists like yourselves out there wanting to get into the field and improve it along the way, I think that makes it even more exciting and gives me even more hope. And I've certainly throughout my career have heard a lot of people complain, and myself included, complaining about maybe somebody who ends up in a leadership role within an agency or any organization who you get really frustrated with how the agency is operating or how that organization is operating. And my perspective was, well, if you don't like what's going on there, then you should get a job there and go fix it and bring in the best collaborators and people to work in that organization and make it the best it could be. And I guess I'm optimistic. I think we're heading that direction.
Yeah, I think I mean, I'm definitely optimistic too. I can't say that I'm always 90% half full, but I don't know. I think I oscillate in how I feel. Sometimes daily. Sometimes I'm really frustrated. Sometimes little wins, keep me going. Little things, and sometimes I get angry. But I mean, I think it all is motivation for me. Even when I'm frustrated, it's like, okay, well, I gotta keep working harder, because in my mind, if I want to make change, to the way things are happening, then I really have to use my voice. I can't give up, because the flip side of that is that, all the industry has a really powerful lobby, and things will just keep going, and status quo will remain unless we actually don't give up, pretty much. And so that's how I keep thinking about it. No matter if I'm angry, excited, frustrated, I try and keep marching, keep going along, keep thinking that it will make a difference. And yeah, hopefully someday, we will get, sort of bigger triumphs than little triumphs. But certainly, I mean, it's a good time. I'm really excited in the fact that there is this debate about scientists and how much we should be advocates and how much we can disseminate our research without being biased. And I think it's really exciting that that conversation is now being had more and more and in the public eye, because that means that people are looking to scientists more to express their opinion and taking what we as scientists have to say seriously and as a good reflection about how management and policy should move ahead. So that's also really exciting. To me, I take it as a sign that people want to listen and want to make effective management based on good science.
Yeah, I agree. And yeah, absolutely with the, those times that you get frustrated and it's maybe something you were working for that didn't materialize or the decision from a conservation perspective went opposite of what you wanted to see. It's not over. You get frustrated, you're upset, but if 10 years later you have made a bigger change than what that one decision would have been, that's what really matters. That what your effort might benefit 10 or 20 years, or you might not even know when your effort is going to provide the benefit. But if everybody just keeps moving in that direction, eventually we'll get there.
Yeah. Don't give up.
That's very motivational. Thank you, guys.
Yeah, that's really very, very much an inspiration and definitely some good motivation to keep on moving in the directions that we're all going, for sure. So we're pretty much out of time here, but I really want to thank everybody for all the early career scientists for coming up with such excellent and insightful questions, and a big thanks to Rob and Leigh for your time and thoughtfulness and expertise and giving all of your thoughts to us and to the online audience. So thank you. Shu, do you want to talk about our next session?
Yes, so our next Meet the Masters session will be on April 9th at 1500 GMT, and it's going to feature Tony Gaston and Sarah Wanless, which we will get together to talk about resolving the differences, the individual and the colony. And we still have open spaces for early career scientists who'd like to feature, like today's panel, so to speak. And we would really appreciate comments and if you could share this video after it goes up, and especially give feedback to us. Yeah, generally we'd love to hear from you if you have any opinion about this.
Great. And just as a reminder, we're on Twitter under the hashtag MTMSC, and you can leave comments on our Google Plus page and comments on the YouTube archive on our channel Meet the Masters WSC2. So thank you for everyone for participating or watching out in the internet land, and we'll see you in April. Thanks.
Thank you.
Thanks. Bye-bye.